Should we begin?
All right, yeah, whenever you guys are ready, go right ahead.
Okay. Hi, my name is Serena Doss.
I'm Victoria Lipkis.
I'm Maui Bayang.
And I'm Max Twiggins. And here is our product, Alarmify, a possible counter to bike theft. After discussing many different product ideas and designs, our group decided on an idea that would help counteract bike theft. I'm sure many of you, if not all of you, have had something taken from you. In this case, a bike could be a fun activity for exercise or somebody's only means of transportation. According to a 2019 article by the Cyclist magazine of bicycling, over 2 million bikes are stolen every year in the United States and Canada alone.
According to the Americans Community Survey's 5-year estimates for the years 2013 to 2017, 872,000 people, or 0.6% of all workers in the United States, are biking to work. The Metropolitan Police Service in London recorded an average of 1,900 bikes that were stolen from March to July of 2019. Even from March to June of 2020, during the pandemic, an average of 1,615 bikes were stolen. And according to the data from the NPD, adult leisure bike sales were up 121% in March of 2020.
Although many bikes are stolen each year, 1 in 5 thefts are reported to the police. This is due to the belief that the police will not take bike theft as a high priority crime. However, there is some liability on the victim as well. Some do not take precautionary measures to make the case pursuable for the police. And due to this, report rates are low, and those engaged in bike theft are unlikely to be caught. This leaves 95% of stolen bikes unrecovered and 2% of stolen bikes recovered. The bike isn't the only thing being taken from the victim. Everyone has a different life circumstance, and if you depend on the bike, it could severely impact your day-to-day life. You would lose your only source of transportation, or your main source of transportation. And without that transportation, you would lose access to resources. You'd also lose the amount of money you spent on the bike. And depending on your economic stance, replacing the bike would be difficult.
After doing research on products available on the market, our group found various products such as the turbo lock and the vibrating sensor system. Some of the common consistencies we found with these products were that they were all lightweight and that the more popular products use an application of some sort. But we also noticed that there were some common flaws that we wanted to change to make our product better than the ones available on the market. For example, with the turbo lock, even though there is an application that allows you to open the lock, there is no way to detect if your bike is being stolen. Another example of issues we saw was in the vibrating sensor system. This device had an alarm attached to it that would help in deterring bike theft, but the alarm would only play on the bike and not actually alert the user that their bike was being stolen.
The following are design specifications. Our first disqualifying design specification would be the ability for a product to send a notification to a mobile device so that when the product is moved, the user receives a notification on their phone. A lot of things that we noticed during our research was that positive reviews usually led to the use of a phone. A lot of people wanted that because they carry that around. Our second disqualifying design specification is that this solution also must include an alarm system on the product that is set off when a movement greater than a 90-degree turn is detected, so that an alarm goes off on the bike as well as the app. Our next specification was for our product to be versatile to different bike types in the market, so we wanted to create an mount that would fit on any bike size.
Our next design specification was that we wanted the device to be no more than 4 pounds so that it is lightweight and easy transportable on a bike. The solution as a whole must also have a 0.25 centimeter tolerance so that the device would remain intact while the bike is in motion. The next design specification we set was that the device must be rechargeable and be able to function for at least 8.8 hours. This number was decided upon because this is the average time of a working day in the United States. And finally, our last design specification was that there should be multiple ways to shut off the device.
Next are some potential solutions to our problem. All of our solutions contained the same electronic components: the gyroscope, speaker, switch, Bluetooth, and Arduino. The first design on the far left would act as a device that surrounded a flexible lock and could determine if a vibration occurred along the length of the lock. We didn't choose this design because it would require us to have a resistant material. Our second idea in the middle was a flower-shaped electronic box which would open and attach to the bike frame like a handcuff. The batteries, detection mechanism, and speaker would all fit inside each of these flower petals. This could be marketable for children and could have open possibilities for a larger market, but we ended up not choosing this design as it required a resistant material. Our third and final design simply would have multiple flexible locks stemming from the sides with wires in these locks. If the locks were somehow disconnected, the Bluetooth would send a signal to the user, but we discarded this idea because we had little knowledge of how to make electronic wiring flexible yet resistant. We decided on basing our final product off of the design which resembled a box.
From our previous designs, this is our final solution. Here are some pictures of our final solution as well as our app.
This is our app. Component 1 shows the current gyroscope position. Component 2 shows the difference between the current position and the original position. Component 3 shows if the Bluetooth is connected to the app or not. Component 4 is the reset button for the original position, and Component 5 displays the original position. Component 6 shows if the alarm is active or not. If a 1 is shown, the alarm is on, and if a 0 is shown, then the alarm is off.
Here is an image of the flowchart of our code. The code starts with connecting the Bluetooth to the app and then reading the gyroscope values. Then the code looks if the switch is on or off. If the switch is on, then it checks the values of the gyroscope and either plays or doesn't play the alarm. If the switch is off, then the code loops and checks if it is still off.
When the alarm is on, a 1 is sent to the app, and if the switch is off, a 0 is sent to the app. The gyroscope values are also sent to the app and to be displayed. Then all the code loops to continue checking the gyroscope values.
So this is the design of the physical product. It was made in Fusion 360. It's a simple box consisting of a lid and the box itself. So underneath the lid, there are these tabs to prevent any sliding of the lid when the two components are together. And as you can see on each corner of the lid, there are holes which are intended for screws to keep the two components temporarily attached together. Also on the side of the box, there's a hole for the speaker so that the sound could be heard and have a better effect as opposed to not having a hole there. As you can see here on the bottom is a layout of the components, the hardware in the inside. And due to the size of the components, the wiring, and plugging in and unplugging the wires, we wanted to have enough room to make any adjustments if needed. Therefore, the dimensions of 4.8 inches by 4.2 inches by 2.7 inches was the smallest we could make the product.
Here's a demonstration of our product on a bicycle.
Good.
In the video, the product was connected to the app on a phone, and when the bike was moved more than 90 degrees, the alarm was triggered on both the phone and the product. Then, when the switch was flipped, the alarm on both the phone and the product shut off.
Now we'll get into the testing procedures. There were 6 different tests that we conducted. For the first test, it was the connection and notification test. It revolved around design specification 1. And with the procedures, it called for 5 trials of the tester walking away from the application with the device at hand and recording the functionality of certain components, which were the gyroscope, the speaker, and the Bluetooth module. On top of that, the tester had to take note of the Bluetooth distance. As a result, all the components were working, and the average distance of the Bluetooth module was 244 feet and 5 inches. Due to these results, we were able to meet design specification 1. Test 2 was the mount adaptability and tolerance test. It revolved around design specification 3 and 5. However, due to the initial conditions of having a mount beforehand, we were unable to test the procedures, which resulted in no results, and we were unable to meet these 2 design specifications. Test 3 was the weight test. It revolved around design specification 4. It called for 10 trials of weighing the product on a scale and taking the average, and as a result, the average was 0.635 pounds. Due to the fact that the average weight did not meet 1 pound, nevertheless 4 pounds, we were able to meet this design specification.
Test 4 was the alarm trigger test. In this test, the tester would have to rotate the box to the left and to the right, as well as tilt the box to its upright position and record the angle that the alarm was set off. 5 trials were done for each the left, right, and upright positions, and the average angles that the alarm was set off at was 91 degrees, 95 degrees, and 93.4 degrees, respectively. Because all these angles were greater than 90 degrees, our requirements for the second design specification were met. Test 5 is the rechargeability test. In this procedure, the tester would have to plug in the fully charged battery into the Arduino and record the start time. Then when the battery died, an end time would be recorded. This test was done 4 times, and each time the battery lasted at least 8.8 hours, with an average time of 9.02 hours. Because the battery was able to last longer than the average workday, the design specification was met. Test 6 is the failsafe test. In these procedures, the tester tested both the switch and confirmed that by moving the product back into its original position, the alarm would deactivate. Both of these methods were tested 5 times. In each of the 10 trials, the alarm was turned off either using the switch or by placing it back into its original position. Because the device was able to be turned off multiple ways, this design specification was met.
So here are some positive and negative common quotes we got from our stakeholders. Most of our stakeholders liked that we had the product linked to an app due to that people nowadays rely on apps for just about anything. They also liked how the app gave them a sense of security and knowledge of the state of their bike, whether it's being tampered with or if it's safe. And they also liked how the idea and concept of our product could be used for more than just bike theft. What our stakeholders didn't like was the size of the product. Since it was too bulky, it was too big, it attracted too much attention to itself, and it seemed too easy to tamper with and mess with the hardware inside. They also thought that would be difficult to hook onto the bike. They also thought that the design of the app could be a bit more professional as it is right now.
Our mentor, Mr. Evans, who reviewed our project with us, confirmed that we met 5 out of our 7 design specifications. He also gave us some criticism and possible future goals for our product. To make the coding process for the app more efficient for both the users and the coders, he suggested using a coding language other than Lua, which was originally used and then had to be changed due to its incompatibility with the Arduino. He also mentioned that by using a GPS, it would aid the users in not only knowing where their bikes were, but also knowing that their bikes were stolen. Lastly, the range of the Bluetooth module was not extremely far, which made our project unreliable if the bike was too far away. To improve this, he suggested upgrading it to a Wi-Fi module, which would have a further range and more reliable connection.
Taken from the suggestions of the stakeholders and engineer evaluation, these are the things we want to add to the product in the future. First is a camera so that it can either take photos or videos of the thief in action. Then we want to have a feature where the alarm can be turned off through the app and notify the user when the app isn't open. We also want to alter the app design to make it more pleasing to the eye and professional. Another thing we want to add is a mount so that the product can be attached to the bike. And finally, a more compact size to make it more discreet and draw less attention to itself.
Lastly, thank you to all these kind people for funding, support, guidance, and time throughout this project. Thank you.
Thank you.
So it's pretty incredible to be able to see all the projects here. This is my 2nd year participating, and one of the things that really comes to mind is as the projects or the products are being presented, one of the things that is really critical is to be able to do a SWOT analysis, list your strengths, weaknesses, opportunities, and threats. And because it really helps you to know whether, you want to buy that product or not yourself, right? And I think, so some of your stakeholders have stated, hey, the distance is not too long. It's kind of limited by the Wi-Fi and so forth. So I think as you guys consider any of your upgrades, did you guys do any analysis in terms of how much it would cost? See if you guys are willing to go and improve your product?
Yeah, we did research on the GPS, but it costs $300 as an initial step to get access to the satellite, and as well as $30 each month for access. So we decided that it's not in our budget currently to get a GPS or a Wi-Fi module.
Go ahead, Alan. I'll let you.
Yeah, no. I like the idea. It's a really interesting idea, rather than just trying to make a super secure lock, just actually notifying somebody. So I give you kudos for your creativity. I also like the fact, I know that you didn't meet all of your goals, but oftentimes when we're working on design projects, there are some goals that are pretty straightforward, and there's known technology out there to do that. And there's some things that we don't know whether they'll work or not. So I like the fact that you concentrated on some of the things that were the harder things, right? So making a mount, a secure mount, that's pretty straightforward. I mean, there's all kinds of mounts that you can do, and you can figure out how to hide it and that sort of thing. But getting the basic concept working and concentrating on that part of it, I think if you had to pick and choose which things to work on, you did a really good job of that. And yeah, I mean, I think, it'd be pretty straightforward to come up with some kind of mount that's screwed underneath the seat, so it wouldn't be as noticeable, be very difficult to take off. Somebody's not going to sit there and unscrew something. But so those seem like solvable problems, pretty straightforward, as opposed to things that you weren't sure if they were going to work. So again, I like the fact that you concentrated on the motion and how that might work. So, the other thing that I might say is a kind of a criticism, or at least a suggestion to think about. A lot of times when you put together requirements for something, say the average day is 8.8 hours, and so you want to make sure that it lasts longer than that. But in reality, when people buy something like this, there may be people that want it to work 16 hours or 24 hours or something like that, and they would be put off by the shorter time. Or maybe somebody works 9.5 and then they lose the power. So when you're looking at those kind of specifications, not necessarily look at the average, but maybe look at the requirements for 90% of the users rather than just the average user. But anyway, nice job.
Thank you.
Thank you.
Yeah, thank you for your feedback.
All right, great job. That was a cool one. I'm going to go out and buy a bike. I have a good bike. I don't want it stolen. Great job, you guys. Do we have Vinny, Nick, and Ethan